Yo, 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 this is Coach Ray. Doing another video, old school this time with the new projector. Notes today are radical form versus rational exponent form. This is the start of a new unit. The new unit's called radicals. And what we're going to do today is convert between radicals and exponents that are fractions. Okay? Exponents that are fractions and radicals are very closely connected. In fact, they're the same thing. So I'm going to show you how to switch back and forth between the two. Okay? And if you can do that, the rest of this unit gets very easy. Okay? Example 1. Example 1. Oh, sorry. This entire lesson comes down to this visual. Okay? So this visual is exactly how we're going to do everything today. And let me start with something even more basic than example 1. I want to start with 4 to the 1/2 power. Okay? What this is saying, so I wrote this in exponential notation, which just means you have an exponent. Okay? My base is 4 instead of x here. And then this fraction exponent, the numerator is labeled as the exponent. And more specifically, that exponent is the exponent on my base. So my base is 4, and now my exponent on that base is 1. Okay, did I really even have to write that one? No, 4 to the first power is the same thing as 4. Okay, but I'll leave it there. Okay, the denominator in this fraction is called the root. So that would go right here, a little 2 outside that radical symbol. All right, now what you need to understand is square roots, okay, with the 2 there, we don't write the 2. It is just understood that if we have a radical symbol like this, that is considered a square root. Square root meaning what number multiplies by itself twice to give me that number inside. Okay, you're not wrong if you write a 2 right there. It's just weird because mathematicians don't write that. Right? But if we do a number that's bigger than 2, you would write that number right there. All right, so I didn't need that 2. I technically didn't even need that 1. So 4 to the 1/2 power is basically just saying the square root of 4, which would be 2. Okay? Let's do a different one. If I did 8 to the 1/3 power, okay, my base stays the same, that's 8. The numerator is the exponent on the base. The denominator is the root. So this is the cube root of 8 to the 1st power. Cube root meaning what number times itself 3 times equals that, and it's just a coincidence, the answer is the same, the answer is 2. 2 times 2 times 2 equals 8. Okay, so that's how we switch back and forth between these forms. All right, looking ahead a little bit, okay, the reason we do both is when we're combining stuff, it's much easier to combine when we're in fraction exponent form, and we more use the radical form to kind of figure out what our answer is going to be. So like over here, 8 to the 1/3, it's not always going to be obvious what that answer is going to be, but when we switch to radical form, it's a little bit easier to get that answer. Okay, so there's benefits to both. All right, let's go to example 1. Example 1 is very basic. My base is x. Okay, the numerator is 3, so that is the exponent on my base. Okay, the denominator is 4. So that is the root. The directions were to just switch forms, and that's what I just did. Okay, that was in fraction exponent form. This is in radical form. Okay, so that's the most basic version of these questions. So far, so good? All right, let's keep going. 343 raised to the negative 1/3 power. You should have a good knowledge of all the exponent rules, including the rule with negative exponents. However, whenever I say should, I kind of know that relies on you having a really good memory and you having a really good teacher in the past that taught you negative exponents. And both of those are not always the case. So I'll just review it anyway. If you have a negative exponent, okay, let's do 4 to the negative 2 power. Okay, I teach this in a very cheesy way, but essentially here's what's happening. This base of 4 has a negative exponent. Negative people are unhappy. So I say that this whole guy, this base and its exponent, are unhappy. How you make someone happy, if they are unhappy, is you just move them out of their situation. Okay? So, 4 over 1. This guy is currently in the numerator. If I move him to the denominator, he's going to become happy. So 4 to the negative second power is the same thing as 1 over 4 to the positive second power. Once he moves, that exponent changes to positive. So this would be the same thing as 1/16. Okay, that's something you should have known before you got here. The opposite's true. If I have 1 over 4, excuse me, 1 over 4 to the negative 2 power, he's unhappy, this whole guy's unhappy. To make him happy, move him. Okay, in this case, I'm going to move him to the top. So I have 4 to the positive 2 over 1. Once they move, it changes to positive. Okay, so 4 squared is 16. 16 over 1 is just 16. Questions on that? Okay, so first thing I'm going to do before I can switch forms is I'm going to make this guy happy. 343 is the base. He's got a negative exponent, so he's unhappy. So I'm going to change this to be 1 over 343 raised to the positive 1/3 power. Once I move him, that exponent changes to positive. Okay, now I'm going to switch forms. Okay, my 1 is still up top. That hasn't changed. Okay, the bottom, 343 is the base. 1 is the exponent on that 343. And the denominator 3 is what the root is. So this is the cube root of 343 in the denominator. That's not the answer yet. We can't have radicals in the denominator. We've talked about that a little bit earlier this year. But I'm guessing that this might actually turn into a whole number. Okay, there is a number multiplied by itself 3 times that does equal 343. Any guesses? 13 times 13 times 13 would be too big. Answer is 7. Okay, if you had 7 times 7 times 7 in the calculator, it would give you 343. So the cube root of 343 is 1/7. Okay, or sorry, the cube root of 343 is 7, but then it becomes 1/7 because we have a 1 on top. Okay? All right, let's keep going. All right, I'm going to write out a step here that you don't need to write out, but I want to write it so that once you understand it, I don't think you need to write this step, but I think it helps you understand it, it helps you get to that point. Okay, there is an exponent rule that says if you have a fraction raised to some exponent, you give that exponent to the numerator and the denominator. Here would be an example with whole numbers. If you had 2/3 all squared, you square the top and you square the bottom, so you end up with 4 over 9. So same thing here. I need it to be 1 raised to the negative 2/3 power over 8 raised to the negative 2/3 power. So far so good? Okay, so now, how many unhappy people do I have? 2. The guy unhappy is unhappy. Sorry, the guy on top is unhappy, the guy on the bottom is also unhappy, right? So I gotta move them both. This 1 to the negative 2/3, not happy at all. I'm gonna move him to the bottom. This 8 to the negative 2/3, not happy because it's got a negative exponent. I'm gonna move him to the top. So in essence, I'm just flipping it. When I originally saw this, I normally would just flip it and give the exponent to both, but this is the reason why that is the case. All right, so let me write what I have. I've got 8 to the positive 2/3 up top over 1 to the positive 2/3 on the bottom. All right, now let me switch forms. Okay, 8 is the base, 2 is the exponent on the base, 3 is the root. Okay, same thing down here. 1 is the base, 2 is the exponent on the base, 3 is the root. Okay, let's start simplifying that. All right, 8 squared is 64, yes? Okay, so really this is the cube root of 64. There is a number times itself, 3 times it equals 64. You should know this one. 4, very nice. So my top just simplifies to be 4. On the bottom, 1 squared, 1 times 1 is just 1. The cube root of 1 means is there a number times itself 3 times it equals 1? The answer is 1. So 4 over 1, the same thing as just 4. So this is a super fancy way of writing the number 4. So far, so good? Okay, a couple more. All right, example 4. We've got the same base, and we are multiplying. So here's just a reminder without fractions. If we had x cubed times x to the 4th, I told you to visualize it like this. X cubed is x times x times x. This multiplication dot goes in the middle. X to the 4th is x times x times x times x. This is clearly the definition of x to the 7th power. I like that visual more than I like you trying to memorize, oh, when the bases are the same and I'm multiplying, you add the exponents. But yes, in essence, what you're doing is adding the exponents. Okay, so since that's true, I'm doing the same thing here. I've got the same base. I've got to add 3/5 plus 2/7. So I'm going to label this as scratch work and leave my x's off for just a minute, and I'm going to do 3/5 plus 2/7. Okay, I need the denominators to be the same in order to add. I think I have to make them both 35. Okay, in order to get this 35 in the denominator, I did 5 times 7. So I've got to multiply by the same thing on top. So times by 7 on the top, and I get 21. Here I multiplied by 5 to get that denominator. So when I multiply by 5 on top, I get 10. Okay, add straight across, I get 31 over 35. All right, don't forget what we did. When I added my exponents, that's just going to be the new exponent on my base of x. So I have now x raised to the 31 over 35. All right, you always got to check, can that fraction be reduced? No, if it could, you would have to reduce it. Okay, but 31 over 35 cannot be reduced. All right, so now since I know my fraction can't be reduced, the question is, did I answer this question? It asked me to simplify, and the answer is yes. Okay, just because it's in exponential form does not mean it's not simplified. That is a simplified answer. In fact, Alex won't even let you plug in radical form answers for questions like this. They make you plug it in exponential form. Okay. However, if I were writing a test, I would probably include a question that said, look just like this. I would say simplify and write your answer in radical form. If I did that, you would have to switch it to be at base of x gets an exponent of 31, and then there is to the 35th root. Okay, so both of these are the same thing. They're both correct. Just know that Alex wants the exponential form as the answer. So far, so good? All right. Example 5. I got the same base, and now I'm dividing. Does it make sense that when you're multiplying, you add the exponents? So if you're dividing, what do you think you do with the exponents? Subtract them. Okay, so my scratch work here is going to be 4/7 minus 1/2. Okay, I need my denominators to be the same again, so I'm going to make them both be 14. Multiplied by 2, so this is going to be 8. Multiplied by 7, that's going to be 7. Okay, this turns into 1/14. Let me pause, I heard a whoa. Are we okay? Too fast? Slow down. Okay, so what I've done so far, 4/7 minus 1/2. I needed to get my denominators the same, so I turned them both to 14. How I got from 7 to 14 was multiplying by 2, so I had to multiply the top by 2 also. How I got from 2 to 14 is by multiplying by 7, so I multiplied the top by 7 also, and then I subtracted. Okay, so just a reminder, so my base stayed the same, so I now have an answer of w raised to the 1/14th power. And I didn't switch it to radical form because Alex isn't going to make you. All right, let me throw a hypothetical out there that will actually pop up on your Alex. Just visualize this and pretend this. And don't miss this because this will happen on your assignment in a couple minutes. What if these were switched? What if it was 7 over 14 minus 8 over 14? How would my answer change? Negative, right? I would have negative 1 over 14. So here, my answer would say w raised to the negative 1/14th power. Okay? If you cannot enter your answer as with a negative exponent involved, so Alex forces you to move it. Okay, so your answer would just look like this: 1 over w to the 1/14th power. Okay, so if we move it, then it becomes positive. This can be plugged into Alex. Yes?
Okay, the way you have to do it is that you have to put the 1 first, and then the fraction, and then w, and then exponent it to the fraction.
Oh, so you're talking about how you would actually plug it into Alex? Great question.
Because that's how I
here,
did it wrong.
the first button you would have to click would be the one that looks like this. That's going to build a fraction. Then you put your 1 in here. Then when you click in this box, you got to click this box so that it gives you an exponent here. Then when you click in this box, you've got to hit the fraction button again to give you a fraction in there. So yes, plugging this in is it takes a while. Start with the fraction button, build your fraction. Down here, you're going to have to click the exponent button. Then when you click in the exponent area, you're going to have to click the fraction button again. That is not simple. I'm glad you brought that up.
The 1 should be bigger than the answer.
Yes. All right. Okay, so we're good. And that will happen where you end up with a negative here and you've got to move it. All right, last one. I've got to simplify. This is called a power raised to a power. Okay, and just taking it back to your Algebra 1 rules. If we had x cubed raised to the 4th power, here's the visual I would draw out. X cubed is x times x times x, correct? Okay, and if I did that times itself 4 times, I'd have x times x times x, times, times, times. And if I did that 4 times, how many total x's would there be? More than that, there would be 12. 3 x's, 3 x's, 3 x's, 3 x's would be a total of 12 of them. So the rule is, if you have a power raised to a power, you multiply. So here my scratch work is to do 4/5 times 7/10. Okay, rule is to multiply straight across, but before I do that, I'm going to cross cancel so that I don't have to reduce later. I see that 4 is even and 10 is even, so I can take a 2 out of both. So that becomes 2, that becomes 5. And now when I multiply straight across, 2 times 7 is 14. 5 times 5 is 25. So what I end up with here is y raised to the 14 over 25th power. You could switch it to radical form, but Alex wants your answer plugged in like this. If we did switch it to radical form, it would be y to the 14th power and the 25th root. Those are the same thing.
How do we know whether or not it's radical?
You got to read the directions. And if the directions say put your answer in radical form, then you would have to switch it. Also, the other way you'll know is in Alex, over on the right side where it gives you the options on how to enter things, they're not giving you this radical button, so you know you can't plug it in that way. All right, that's it for switching forms between radical and rational notation. It's been real. Thank you all for being here. Catch you in the next one. Deuces.